We were aware, and the energy efficiency folks have been aware for a long time, that high MERV filters can reduce particles. There's also significant concern that high MERV filters are not appropriate because they are too restrictive. So our initial question was, is there an easy way to determine? How do you tell somebody whether or not they should use a high MERV filter with a longer air handler runtime, 24/7 or even 50/50, without creating problems? So that's what we set off to answer. And that's one thing that we answered definitively fairly quickly. It took about 5 visits, and the answer is no. You absolutely need a diagnostic screen in order to determine whether or not, particularly if you should run it 24/7. So we developed a checklist, and it's here on our website under air handler inquiry. So this is something that you could look at yourself, but you could also share with an HVAC contractor and just say, can you do this analysis of my furnace or AC system? Most air handlers are operated by a thermostat. This is a typical programmable thermostat that probably 90% of all HVAC systems have. And the key thing it has is a switch that allows you to set it on auto or on. And most people set their air handlers on auto, and there's good reason for that. And in that case, it will only run when there's a call for heating or cooling. So that's the typical operation we see, and I'm not criticizing that. But the problem is that means the runtime is only about 15%. This has been shown study after study, but that even with central AC as well as, or central, air conditioning as well as heating, that when you consider how many hours are in the entire year, the air handler is usually only running 15%. So it's not enough if you're trying to filter. The best filter in the world is not going to help you running 15% of the time, particularly with Pittsburgh's air quality, but even just with indoor sources. So the call for heat and cool doesn't align with the need for filtration. Now, there are smart thermostats, the Ecobee or the Nest, and there's some others that give you control, because you can, from your smartphone, you could say, run 50% of the time or run 30% of the time. So that is a neat feature, and actually we've been incorporating smart thermostats in our air handler inquiry to give occupants more control. So here are the problems we found. The cost is invisible. You can't easily meter the cost of running your air handler, and it can be really high. So if you run it continuously, we're talking potentially big bucks. There are a few that we've seen that are less than 500 watts, but we just recently ran into one that was 1200. So you're talking a lot of very high costs to run a typical air handler 24/7. They're usually set on high, and they're very seldom set in the field. They're set on factory default. HVAC contractors don't go in and check and then change the continuous speed to low, which it should be. If you're running continuously, you want it in the lowest possible speed. So part of this high cost is because it's running on the highest flow rate possible. And that's not the best of filtration. The best filtration is a much lower airflow rate because you're dropping more of your small particles. So Monica, I don't know what you've seen in the work you've done, but this is a really key issue. We actually did run into 1 or 2 that were set right out of 75. It was really neat to see that, but that's not the norm. And normally the static pressure is too high. Most people don't have a clue what static pressure is. It's like, what the heck static pressure, total external static pressure, TESP. But it's all about whether or not the amount of air you're trying to move through the duct system is appropriate for that duct system. And basically, most of the cases we see, the static is too high, which can lead to equipment failure. Now, a clogged filter can also lead to too high a static pressure. It can be undersized ductwork, it can be oversized HVAC system. But anyway, this whole issue of whether or not the air handler system fits, is properly sized for the furnace or AC unit is a really big one. And then the other issue is if you've got any duct problems, particularly if you've got ducts in an attic, a garage, a crawl space, you can have tremendous energy waste, pressure-related problems, humidity issues. So anything wrong with your duct system is only going to be worse if you run it 24/7. This is what we've seen, and this is just a plot. It hasn't been upgraded, more like 75, but basically huge number of systems with static too high, all of these. And actually HVAC oversized is larger. It's just that we didn't actually do the numbers or anything so this was just a crude summary, but we probably see oversized systems in 70% of our homes. Obviously, it's more common in an AC system than a heating system. But another issue is that no matter what filter you've got, if you've got a filter bypass, and ironically also if you've got leaky ducts, your static might not be as high because it's not restrictive, but it's also not working. So this is something just to check on next time you stick your a new filter in is, gee, is it a good fit? So here's what we think you need. And we basically don't recommend that you use a 1-inch pleated MERV 11 or 13 filter without performance testing. And if you do have an air handler that only holds a 1-inch filter, you should probably be changing it, as I said, every 3 weeks, 4 weeks during the winter and summer. So with an ECM, electronically commutated motor, you've got more control over airflow. So you can set it to a lower setting and you can also drop the electricity use. However, static pressure has to be correct. The worst systems we saw were systems that had an ECM blower, but a very restricted duct system. And in that case, the energy use was far worse than the old-fashioned inefficient blowers, interestingly. So we like the deep filters, 4 or 5-inch pleated MERV 13 filters, but not just the filter in its original size, but also a larger area. And that means that there's less airflow through the filter, and the filter basically performs differently at different airflows. And it's going to reduce more small particles and ultra small particles when it's lower airflow. But you really want a good duct system. You don't want leaks to the outside, and you want the airflow and total external static pressure to be within nameplate specifications. Every HVAC system sold has specs, and systems, when they're installed, they should be checked against those specs. So this just shows you the reduction we saw. This was the pre-median and the post-median. Here we go for the reduction in just the watt draw from initial operating conditions, and then once we made the air handler intervention change with an ECM. This is the graphic of what, similar to what you saw in the video. Bottom line is normally if we do everything, the labor and material would be about $1,000, and $10 to $15 is a typical monthly electrical energy cost of our post retrofit. That would be lower in a furnace that you bought that had a really good, the better ECM. We're basically using dumb ECMs because that's the only thing you can use as a replacement. But the new furnaces and AC systems that have the upgrade to the best ECM, you could get this cost down to $3 or $4 a month. So really low for 24/7 operation. So another just shot of what we saw. You can come back and look at these slides later. Pre-post results typically go from red to yellow to green. The added interesting thing is that because you're running the air handler 24/7, you get better mixing throughout your house. So if you've got a house with a high CO2 in the bedroom, you're going to have better mixing. If you've got a house that's not comfortable in the summer on the second floor, you're going to have better mixing, so even better comfort. So something to consider. We typically do put the larger filter in, not just the same size filter, as well as the deeper. Here you see what's typical, that the air will be uniform throughout the house because of the mixing achieved by the air handler. And this one's like 10, 15, amazingly low counts, even when the outdoor was really bad, in this case, hitting 10,000 and between 1,000 and 10,000, which is like the worst possible outdoor air that you see. So big opportunity to replace the HVAC system, and that is that if you properly size an HVAC system, guess what? The ducts might not be too small. And if you haven't done stuff to reduce your heating and cooling load, it's a great time to do it before you replace your HVAC, because you can put in an even smaller system. You could also incorporate the return drop modification and make sure that the filter is a larger, deeper one. Ideally, when it's installed, it should be installed right. You should request that you make sure that you check and set the blower speeds and check the static and all those things. When you replace a system, a good HVAC contractor should address any shortcomings in your duct system. And it seems like the combination of health and efficiency and performance could really drive to allow good HVAC contractors who want to do it right rather than just be low bid could really do a better job of competing effectively if people were more aware of what they're losing when they go with HVAC low bid. So this is what we want. Deep, large, low resistant, minimize bypasses. Bottom line, it can work, but don't do it unless you confirm. And there's good news. The good news is we really need larger integrated solutions that go far beyond filtration. I obviously need better outdoor air quality, and we need champions.